Hello students, today I am discussing the topic wave particle duality. As we know that interference, diffraction, polarization, these phenomena explain that wave nature of light. That is a wave, the interference phenomenon for wave, diffraction phenomenon for wave. On the other hand, if we see or consider quantum effect, photoelectric effect, all these phenomena, there is transfer of energy, bundle of energy, transfer of momentum. That radiation means transfer of energy or momentum. So that is bundle of a particle in that phenomenon. If we go through that phenomenon or consider that phenomenon. So in that case we can say that is the particle nature of light. Okay. So both the nature, if we consider, that is wave particle duality. So student, if we consider the particle nature, the evidence is Compton effect, photoelectric effect. Particle nature means when radiation transfer, that is light is also electromagnetic radiation. When it is transferred, that is bundle of photon. Photon is chargeless, massless particle. Transfer of photon, bundle of photon. Okay. So if radiation behaves both like wave and also particle, then why not elementary particle of matter? Means so many elementary particles are there, proton, electron, neutron, and so many. These are the very common. So these all the elementary particle will show that wave nature and particle nature both. So in this way there is a hypothesis of or assumption first proposed scientist Broglie. Broglie scientist proposed that matter wave on all the material particles are associated with a wave. Any material, any particle, it may be electron, photon, or big particle also, when it is moving, there is a it is associated with a wave. And he proposed a relation, that is lambda, the wave associated with the particle is equal to h by p. P is the momentum. So this is the matter wave, wavelength is lambda, and the particle nature when it is moving, that P is the momentum. That is called de Broglie wavelength. Lambda is de Broglie wavelength. Lambda is de Broglie wavelength. Now this relation, that is when any particle moving with momentum p, the associated wavelength of that particle, moving particle, lambda will be equal to h. H is Planck constant, h by p. H is equal to Planck constant. This relation is experimentally verified. That matter wave, that this relation is experimentally verified by X-ray diffraction. X-ray diffraction of crystal. When X-ray is passing through, X-ray means flow of electrons passing through crystal. There is lattice crystal lattice plus basis means crystal is made up of lattice and basis, that is basis means this atom, and when X-ray is passing through it is diffracted and it is measured from by calculation that the wavelength exactly match this de Broglie equation or de Broglie wavelength. Okay, that lambda is of the order of the lattice space, means the crystal, the spacing between the two atoms in the crystal. Okay, so this relation is experimentally verified, and we can say that it is just the proposal is de Broglie's wavelength, and the de Broglie's hypothesis, it is the very correct and very true experimental proof. Now this question arises as I am telling that de Broglie's relation or equation, it is valid for any kind of material, particle, for all material, whether it is photon or it is electron or it is proton, and it is a bigger size of particle or material. That matter wave, de Broglie's wave relation or equation will be satisfied. Now the question may arise, if it is satisfied for bigger particle, then the particle which we can see in our eyes, through our eyes, or we can feel, realize that particle, we never see that this particle, that there is a wavelength or wave associated with the particle when it is moving or when it is there. And if de Broglie proposal is true, then all particle will be associated with wavelength nature. But we cannot see, because for as the size of the particle, or it is a bigger particle, then its momentum will be higher. Its momentum will be higher. P as P increases, lambda will decrease. Okay, now the wavelength is so small, we cannot see, we cannot detect this wave of the bigger size of particle. The wave is associated with all kind of particle, bigger or smaller. The size or mass, when it is the size is increasing, then the wavelength also decreases. And wavelength is so small, we cannot, it will not in our visible region. Okay, because electron and that small particle, it is electron means of the order of 10 to the power minus 31. Electron means of the order of 10 to the power minus 31 kg. Such a small, the wavelength we can detect. But for bigger particle we cannot detect, because momentum will be very high and lambda will be very less. Now student, there is a very tricky question, Neet 2023. Is it totally based on concept about the subject or concept of physics, that the minimum wavelength of X-ray produced by an electron accelerated through a potential difference of V volt is proportional to 4 options are given. Now here we have to use the de Broglie equation, or we have to calculate the de Broglie wavelength, but nowhere it is mentioned that you are to calculate the de Broglie's wavelength. It is only said that the wavelength of the X-ray. X-ray means flow of electron, means wavelength associated with electrons, means we have to calculate the de Broglie wavelength of the electron associated with it. Okay, now here we have to think in this way. Otherwise the problem is very easy. But since there is it is not mentioned about de Broglie, nowhere it is the term de Broglie's wavelength is mentioned, most of the student, many of the student cannot detect that we have to calculate de Broglie's wavelength for this problem. But if you can realize what you are going to find, then it is very easy problem. So the energy of the X-ray or the electron, since it is accelerated through potential difference V4, so energy E equal to small e into V, because it is accelerated through potential difference V. Okay. Now energy E equal to half mv square, means half p square by m. So this is equation 1, this is equation 2. Or we can say that if we equate these two, so it will be is equal to p square is equal to p square by 2m by equation 1 and 2. P square by 2m is equal to EV, or P square is equal to 2MEV, or P is equal to square root of 2MEV. So this is equation 3. So this is equation 3. Now if we put it in de Broglie's equation, that is lambda is equal to h by p, that is equal to h by square root of 2MEV. Okay, equation 4. So we can see lambda is proportional to 1 by square root of v. That means option 4. This will be the correct answer. Okay, the problem is very easy. Only we have to use de Broglie's equation whether it is not mentioned. That is the trick. Otherwise, it is very easy. I hope you understand my lecture. Thank you.